quickly. Multiple mode changes. If you're switching stuff around and selecting your glyphs, you see a little more peaks. And the serial port is like this steady power consumption. So for those that are into graphs, I don't know, I thought that was kind of neat. This is something I'm really proud of because I'm not really an analog guy. I'm just a digital guy. I design embedded systems. And having to like take out and use a MOSFET and a diode was like cool. I'm a real engineer now. So the seamless power switching was something I mentioned was really important just because you had the battery in there, but why run it on the battery all the time if you're going to plug it into your computer? But what's also cool is say you plug it into your computer, then you want to take out the battery. You can do that and the system's not going to crash. Or say you have it plugged into your computer and then you want to go mobile. You can plug in your battery and then take out the USB and you're still going to be up with no glitching. So the way I have it set up here is there's a, God, I hope I remember this. This was a long time ago when I did this. I have a P-channel MOSFET that's on by default because I have R4 pulling it down. So that's going to be on by default, meaning that VBAT is going to connect to VCC, and then VCC is the system power that goes everywhere else. When the USB is plugged in, then the 3V3 out, which is from the FT232, which is it's a 3.3 volt low dropout regulator output that's used. It's like a 25 milliamp current source. So you can power some things with it when you plug into the USB port. So that line goes high and turns off the MOSFET. And then the battery is isolated from the circuit, and then you have the D5 now passing current the other way from 3V3 to VCC. And there is a little bit of leakage from the body diode of the MOSFET, so there is some leakage coming back into the battery, but it's really, really small, like nanoamps, and that's okay to back power a lithium battery at nanoamp range. But if it's something larger, and like say you put in a different MOSFET for some reason, you could like explode the battery. And then the one other interesting thing is the voltage drop across D5 causes VCC to be lower, so we're not actually seeing 3.3, we're seeing like 2.6 when we're running it off the USB port. And there was all sorts of problems that I ran into with diodes because you always think of a diode as being this ideal device, right? It's like you let current flow one way and it blocks the other way. But it's not really like that in the real world. Current will flow one way, and but then there's leakage backwards, and then there's the voltage drop across the diode. So basically, the higher the voltage drop, the less leakage, the less reverse leakage you have. But then the higher voltage drop, you lose that voltage. So I was going with a really low voltage drop device because we were on 3.3 volts. I was like, well, I don't want to drop it too low. But then I was actually powering the device through. I was powering the FTDI part, the USB to serial adapter, through the battery, and the thing was coming on, and it's like, that shouldn't be on. So it was this whole problem, and I switched out the diode to just a more general purpose one, and it worked fine. And here's some other pretty pictures. So this is switching from battery to USB. God, you can barely see that. But VBAT's at the top, and then you can see 3V3 out is low, and then when you plug in USB, it goes high. There's a tiny little like 50 microsecond glitch at VCC when it drops from battery voltage down to the USB voltage, but totally works. And then here's the other way of USB to battery. So say you have it plugged in and then you pull it out and it goes back to battery. You see a little like half volt droop, but that doesn't affect the system operation. And you can see the battery or 3V3 out sort of drain, and then the battery stays level. So all sorts of neat stuff. Badge types. Here are the different quantities. So 7,000 human. Sorry, it should have been like 10,000. But live and learn, I guess. You can never correctly estimate it. And people are always like, well, why don't you just order more badges? But it's, those badges cost money, and it's hard to get stock, and then we don't want to end up with like 2,000 leftover badges.
And then this year there just were no more parts.
Yeah, so that was the other thing, is we originally actually were going to do 6,000 human badges. And after I'd ordered all of the parts and got everything sent over to the factory, Jeff was like, can we order more? We should probably order more. And I'm like, all right, so we ordered 1,000 more, but it turns out that I called up Freescale, I called up all the distributors trying to get 1,000 more of the 56F8006 semiconductor. There was only like 1,000 left in stock in the world because all the factories now are on what's called on allocation, and they're so backlogged it's ridiculous. Like parts now, anywhere you look, most parts have like a 17 to 26 week lead time. So we could get parts for next DEFCON, but not for this DEFCON. And that's anywhere you look. So we could only end up buying 1,000 anyway, so it's lucky that we only did that. Yeah, just really wild. So let's see, Uber, there's 30, so you want to get one of those. Actually, yeah, so what I didn't mention in these slides is you guys remember like all the customs issues we had, right, from the 2 years ago and last year, where parts were getting stuck in Chinese customs going to the factory, so they couldn't even start manufacturing badges until like the Monday or Tuesday of Black Hat before DEFCON. And then, of course, you know what happened.
That was the year of $30,000 of overnight FedEx charges.
Yeah. Which brought the cost up of the badge a lot. $30,000 of, FedEx loved us that year. So getting stuck in Chinese customs just was not an option anymore. We couldn't take it. Like I couldn't come up here again and say, sorry guys, the parts are stuck in customs. So as luck would have it, eTechNet has had a lot of problems with customs going into China. So they ended up setting up an office in Macau, which is a special region and has different customs rules than the rest of mainland China. So we could send stuff to some person at some law office somewhere, which is just some one room in a gigantic building somewhere. We can send all the parts to Macau, and then somehow they smuggle them into China, into mainland China. I didn't ask how, but it worked great. And so all the parts got through totally fine. We did have a few problems coming back into the U.S. when all of the badges were built, because of some documentation problems. We were shipping it to the Black Hat warehouse, care of Caesar's Palace, care of some other warehouse with Joe Grand, and there's all these addresses, and customs, I guess, is getting really strict trying to bring stuff into the U.S. now, and I heard they hold stuff all the time. So there's a documentation issue that Ping took care of, and the good thing is at least they spoke English, so it was easy to deal with that, and like the next day the parts came through. So that was the only little hiccup. Here's the little time chart that I always show. This was interesting because it's like half the time was on firmware and half the time was on hardware. Let's see, research, meetings. We didn't really have a lot of meetings, and administrative stuff. Compared to last year, so it was 150 hours total. Last year was, I can't add that up so quickly. A little more. I think it was like 160, and the year before was 180, so we're getting more efficient.
Yeah. The less time we're stuck in customs.
Yeah. Less time waiting. Okay, so badge hacking contest. Once again, Jeff is going to help me judge, so you guys don't think that I'm playing favorites, because I don't play favorites anyway. But Jeff's going to help me because last year there were so many submissions and there were so many good ones. We're like, oh my God, what are we going to do? And I call him like freaking out, trying to get some help. So we're going to be judging the entries, and you actually get to win a black badge if you win the contest. And I have all sorts of prizes. I cleaned out my lab and cleaned out my closet and stuff, so there's all sorts of cool things that you really want. Freescale's actually given a bunch of dev tools and stuff to give away. So it's definitely going to be worth doing. And we're awarding the top 3. Previous entries, if you want to read all about the contest and stuff, just go to my website and check out like the DEFCON 14 badge or whatever. All you need to know is at 2 p.m. on Sunday in the Hardware Hacking Village is when we're going to start taking submissions. So I'll be there. Jeff probably won't be there, but I'll give him the rundown when we start deliberating the results. And I'll take pictures and video it and everything, and you have like a few minutes to show your stuff. So I hope to see you guys there, and we're looking forward to what you can do, especially if you're not into hardware, if you're a little bit nervous about the hardware, you can still use the USB serial port and do something cool.
I think that's a different category. There's the people who do all hardware and the people who do software.
Yeah, we haven't exactly decided how we're going to judge stuff and who's going to win, but maybe there'll be multiple winners, right? Software only or hardware only, but we're not going to tell you that because we don't want to limit you. You just do what you do and make your project and hack your badge, and then we'll decide what to do about it. So that's actually it, and we have some time for questions. For the first time ever, people can ask questions in the room. You have to use a microphone, and yeah, and I guess before people come up, just to reiterate what Jeff said is, we've been doing the electronic badges for a long time, the 5th year, and I feel like we've sort of, if we haven't solely set the trend, we've kind of helped push that. And conferences and parties are doing electronic badges everywhere, which is awesome. Everybody has their own constraints, and it's cool to see what people are doing, but I think it's safe to say that we might do something different in the future. If I'm involved, and we'll see what happens. But it's been a fun ride so far, and thanks for coming. And stay if you have questions. Any questions? No.